Hello, sir. This is the second video to explain, to continue explaining our code. So we reach here to load it the line data. So before we go to the initialization, we want to explain the line data. As you see here, if you open this is the line data. The line data is contain the number of line, the sending end pass and the receiving end pass, and after that the resistance and inductance and capacitance for each line, as you see here. So, and after that, as you see from here to here, this is the tie line. So it's included in the line data because the program you should to optimize this tie line with the line in our systems. So this is the line data, what you contain. As you see here, this is the number of line 20, the sending end is 20 and the receiving end is 21, and this is the specification of the line. And after that we loaded that, we start. We have a loop here to optimize, not optimized, loop for the number of population. As you see here, this is the initial position for the populations, as you see here. And this is the loop, as you see here, from here, I think from here, not from here. This is the loop, as you see here, the while loop. So if the program is enter this loop to initialize, the first thing, initialize the particles, the position randomly, dependent on the maximum and minimum variable and the size of variables. And after that initialization, initialize the velocity as zeros, and after that evaluate what? Evaluate the line configuration. This is the constraint. This is the function of the constraint. This is function is main object for that function is two things: remain all the bus connected with the supply bus, and remain all remain the system as a radial system or radial distribution system. So this is the main function for that code. We will explain that later. And after that, this, as you see here, we enter the particles from the position that initialize randomly in the line configuration, and after that we get it to output. The output, the new line. If you have a new the new line, and after that the new line mean that which is line is open, which is line is closed. So the line should be 86 line, not like the line here. Line here, we considered all the line with the configuration, but here this is the what the optimized what the particle open the line or close the line. And after that, if the FA factor, this is factor, is equal 0, you can apply this this particle or this is assumption in the load flow. If not, the cost will be highly, because this is configuration not applicable, because maybe some line not connected with the source, or some line not make the configuration is radial. And after that we updated personally pest, as you see here, and then we as you see here, from here, sorry, from here to here, as you see here, why you ask us why the program initialization will take time, because we have here a while loop, not exit from this while loop until to reach randomly particle position that achieve the constraint. So this is while loop will be open it until to get the right configuration of our system. And after that, we exit from this loop to apply this load flow or this function. So this is why the first or initialization function take a time, and why do that to in the first step the randomly to get the the applicable particles. So when we get applicable particles, so this is will be more easy for optimization to get the best result. So we maybe wait some time, but this is a way to easy the optimization function to get the best result fastly. And after that, we applied these lines on the load flow. So this is and calculated the fitness function of the load flow. We will explain later. And after that, we updated the personal best as a particle position part, because this is variable is not defined until now. So in the initialization, the best position is the current particles, because we don't have any previous thing. And after that, we updated the global best cost between all the particles. What do you mean personal particles and the global particles? What's the difference between two variables? So the first thing is the best personal best for each particles, for each position. But the global is for the all particles, which one is best. So this is the best one. This is each particles the best position for each particles in each iteration. Maybe we will explain also later. And after that, we repeated that number of population. For number of population, and after that also to decrease the complexity of the program and get the best position as much as. So we repeated the randomly initialization more than one, repeated 3 times. And after that, we go to the PSO main loop. So this is the initialization function. In the next video, we will continue in the PSO main loop explanation. Thank you very much.